Okay. Hello, everybody, and welcome back to the Azure podcast. My name is Evan Baslick. I'm here with my fellow co-hosts, Cale and Sujit. We are recording this on June 4th, 2024. This is episode number 496, and we're going to talk about some cool technology called Azure Boost. We got our special guest, Niko Pamboukas here, and Siri Velauthapillai here with us. We will fix that later. But before we get to our special guests, let's go ahead and talk about some news.
Yes, I've got a few in there, Evan. So the first one is Azure Bastion Premium, which they announced late in May. And this is a new SKU that offers two things. It offers recording of your session, your Azure Bastion session, and also it allows you to connect to Azure Bastion via private endpoints. And so this gives you that additional security for highly sensitive workloads where they have to allow maybe an operator to log in remotely. So that's the first of the lot. Second one's related to Kubernetes and the logging feature in Kubernetes. Kubernetes can export logs to Container Insights and Azure Monitor. And now the new schema of the logs this is the V2 schema for container logs. It adds a lot of interesting metadata onto the log. So every entry now has things like pod labels, pod annotations, the image name, the image ID, where the image came from, which repo, etc., and the tag. And so all that additional metadata allows you to kind of filter the logs in interesting ways, on Azure Monitor. So that's certainly a nice feature if you're using AKS. Third one is related to Azure Load Balancer, and what they've added now is in public preview are health events. So the health events, like as Azure Load Balancer is operating, it's keeping a track of it, and maybe sometimes it's degraded or it's constrained in some way, and you want to go back later and look at them. Hey, historically. What happened at that time, right? Some user complained that they couldn't log in. Okay, there was something wrong with Azure Load Balancer at that time. So it kind of saves those health events for you, and you can kind of go back and look and see what happened there, and also do troubleshooting in real time. And then the last one I have is related to Azure Chaos Studio. It supports a new interesting feature called the process pause. Actually, it's pause process, and what that does on Windows machines, you can actually just freeze a program that's running. And why that's interesting is that it almost simulates like the program's glitching, right? Yeah, you have a normal application, it's responding, you freeze it, now the application is not responding, and the idea is to see, okay, how does your system react to that, right? To like a momentary glitch in your application. And so that's the new feature that's generally available.
I want to, so I have one announcement, and I also want to loop back around to the load balancer thing. This is sort of a pet peeve of mine. Thrilled to see the events here. It's great. I just want to remind everybody, 99% of the time, it's because the backend resource stops responding. The load balancer itself is not really a thing that can break. There are rare occasions, but like just because the load balancer says the endpoint was down, don't go look at your backends first. It's the right place to start.
And sorry, and that is in fact one of the kind of events that they put out now. It's called No Healthy Backends.
Absolutely, yeah.
So they are putting that out now.
Yeah, no, absolutely, yeah, 100% agreed. There's just this. I've had people over the years say, "Hey, can I go get a network trace on the load balancer?" Not really a thing. So it's always been a soapbox for me. The other thing along the load balancer piece, we've also released, and I love this feature, this admin state feature, which this allows you to go in through basically CLI, portal, whatever, and manually take an endpoint out of the load balancer temporarily, right? The old trick was you had to like block the port, and you risked other things going wrong, and now you can actually just do it at the load balancer level. Great when you have to take one instance out to go do an update or something like that, but you don't want to go monkeying around with sort of your general load balancer settings or changing things on your virtual machine itself. So that's a great feature for load balancer. We've needed that for years.
And this is one of the backend endpoints that you're going to take out. One of the available backends.
Yes.
Okay.
Yeah. So think about it, you got like 2 VMs behind, and you want to go update one.
Right.
Used to be you go in, you RDP into it, you block the firewall, port, risk other things happening.
But isn't it like if the port is, yeah, if the port's not, you take the port down on the server and the port doesn't respond in time, does it not automatically take it out
It,
if the
it
back?
it 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 will, but then you have the problem of like, well, did you block the? So we get sort of into this, but like, the load balancer, you may or may not set the load balancer probe on the port that goes with your application. That's a common mistake. If you may have some automation that says if this thing stops responding, take it out of the like kill it automatically. There's all kinds of logic that people have when things go wrong with that back end that it just gets risky. In this case, the probe doesn't change, nothing changes. Load balancer just sort of adds another layer of logic that says, hey, just don't send traffic here, but everything else just behave just like you would normally. Does that make sense?
Yep. Thank you.
Yeah. Cool. Yeah. So, okay. So Cale, anything from you?
No, I'm all good today.
Okay. Awesome. We're light on news after like 2 weeks of just a ridiculous number of announcements from Build. So that being said, so let's get over to Boost. Azure Boost is something that we announced, I believe, publicly a couple, 3 months ago. We sort of had a whole bunch of announcements at Build. Niko and Siri have been heavily involved in, building the feature, and we thought it'd be good to have them to come on and explain. Like Azure Boost, like doesn't really tell me anything out of the gate from the name. So like, tell us what this thing is and why it really matters. Why it actually is a really big deal in the Azure world. Yeah, go ahead, Siri.
Yeah, so Niko and I are part of the Azure Build team. Why is this important? Why does it matter? The main thing is this lays the foundation for not just what customers could get now, but also down the road, specifically around the area of networking and storage I/O coming in from your instance. And some of this you directly see if you're the customer, if you're running a VM. Some of it is indirectly if you're running in containers or consuming services. And so in terms of networking and storage, I want to hand it over to Niko to sort of introduce the networking improvements there.
Yeah, and I'm Niko Pamboukas. I'm Siri's peer on the team. And one of the things, again, like Siri mentioned, that we think about, as a customer promise and what customers are asking for is, the notion of speeds and feeds, but also this notion of quality, and quality as it pertains to, hey, as you continue to give me more bandwidth, lower latency, improved RDMA, how do I take advantage of those with my virtual machines as a customer? And, how does that apply to my workload? And one of the things that, we're hearing, and again, we're, reacting and not only to customer feedback, but essentially where the market is going, is driving these higher bandwidths, but also giving them, as we sell newer VM sizes that take advantage of this, right? That's the key thing. We don't sell Azure Boost. We probably should start with there, which is Azure Boost is a system of capability that we enable within Azure.
Yeah.
It's purpose-built hardware that has, obviously a software component to it as well. And that it allows us to kind of accelerate, build our own network interface, our own NIC card, enable, NVMe, enable faster throughput, lower latencies, and giving customers the control they need through these larger and faster VM offerings. But at the same time, there's also an internal benefit on the platform side, which is as a customer, I get this faster, better stuff, the cheaper, better, faster, but I also get, things from lower jitter and improvements that come with the Boost platform and the Boost architecture. And so what we see is the trend of, hey, it's great that I have all these features in Azure, but I kind of care for my mission critical workload. That when I get these things, whether it's the throughput or the storage performance, I want other things like an improved capability around when you do service and maintenance on these components. What happens then? How do I get less impact to me? And so customers are coming to us with a lot of questions from a lot of different vectors, which is I want speed, I want good cost performance, I want low maintenance impact, I want all of these things. And so that allows us to think about, well, across the entire Azure portfolio, how do we enable that at scale and equally across whether it's Intel or ARM or AMD or AI SKUs. And so that's the trend that we're seeing, and it's driving a lot of the innovation that's going to be coming from Boost, the current versions that's out there today with the current VM sizes and specs, and then the future versions that we're working on as well.
This, to some extent, this goes back to, I believe, when we started, we just sort of took servers and put them in the cloud, right? Wrapped a whole bunch of management stuff around it. What y'all are talking about here is really offloading some of the things that we do, offloading them to this special processing hardware plus software that we have, right? Freeing up resources, and that brings the quality, that sort of brings, better speed, good, bigger, better, faster down the road. But this is really something you wouldn't have to do on premises, right? This is really a sort of a custom built thing for the cloud and custom built thing for our cloud, right?
Correct.
Go mute, Siri.
Mute. Yeah,
Hopefully we
do
could cut
it
that
good
out.
together.
Correct. This is hardware and software optimized for the Azure infrastructure, and the point to sort of highlight here is by doing it in specialized hardware, we use an FPGA plus ARM SoCs. It allows us to do the data plane acceleration and control that a lot more. So Niko mentioned, servicing downtime and also jitter. If you're doing it at a hardware level, you're much more fine-grained control of that versus a CPU with the scheduler in it.
Right.
And at the other side of it, it also improves your security boundary. You have this additional layer of hardware isolation along with the software isolation that we already have in Azure. And then the third point, this is, Niko was alluding to this, which is by doing this, we want to make the onboarding for customers easy. And there are instructions on the website, aka.ms/Azure Boost, but it is not something where the customer has to significantly change their workload. They can do lift and shift from their on-prem onto Azure and follow our instructions, or move from another cloud provider to us.
Yeah, my question was going to be along those lines, Siri. So just pulling back from brand new to Azure, and this sounds like this is VM centric, so this is for VM based workloads. Is there anything I should be thinking about as a customer to say, I already heard about this Boost thing, so I should be putting my stuff on specific type of VMs in order to take advantage of this? Or is it no, bring your workload and we'll help you? Like you said, there's a website to kind of help people through this. Does that help them migrate their stuff? Do they have to migrate their stuff? What's that situation look like?
So these two levels of answers. To get the highest performance, network storage, controlled jitter, and lowest latency, taking advantage of the latest drivers and latest versions of the OS you're using within the VM. So using the latest version of Windows Server or Windows Client, various flavors of Linux that has all the optimizations to take advantage of this hardware. Part of the reason I mentioned that is as you provide higher performance in Azure, you also need the client OS to be able to feed that amount of data. And you need both sides to plug together. Then the second part about that is how to identify is on our website, it has more details on, hey, here are the VMs and here are the specific performance for the new VM sizes. For the existing VMs, one of the key investments we made, and Niko's team did a lot of work on this, is to make sure that by default, you need 0 changes to work on this. We built an emulation layer. You don't get the highest performance with an emulation layer, but it's a very tiny emulation layer so that you don't have to do changes and you could call into the existing hardware. Niko, do you want to?
I was saying, let me just make sure I understood that right, because I think that's a super key thing, because y'all talked about here's how you onboard to the latest and greatest. But I think what you also said is really, if I don't do anything, I do get some benefit. If I want to get the most benefit, I do have to, pick the right VM SKUs and sort of push the right, load. But I could theoretically take a workload I'm running today in Azure, just go up, pick new SKU, update to the latest and greatest drivers and OS in my client, which generally, fingers crossed, shouldn't be a huge deal, right? I don't have to re-architect my whole application to get this benefit by and large. Did I catch that right?
Correct. Correct. And it's the ethos of Microsoft. Started with Windows, which is we don't leave our customers behind. And so you just keep going. But just want to emphasize, if you want the lowest latency or the highest performance,
for sure.
you need that. Yep.
For sure. Yeah, for sure.
Yeah. And again, we have an amazing sister team who's built this technology, this translation layer. For the customer who says, I don't know, I want to land on that new hardware to run there, but I haven't had time to make necessarily the changes. So you run there, and of course, there's instructions. If you want, ultimate peak performance, you get the driver, you qualify it, you're good to go. So you're covered from both sides. So it's a good way to take care of all the workloads. And then for those who want max horsepower, max performance, they know what to do.
Can you give us some examples of some workloads that you see customers have quoted as being able to take advantage of this new Azure Boost? Like when you went through the initial, I guess, private preview, or that's like what kind of workloads have customers been putting on there?
Yep. Great question. I could speak for, and we have many examples, but last summer when we started the preview with some friendly customers, one of the biggest things that some customers have is they still want to move their databases that are on-prem connected to a storage area network SAN and do minimal development effort to run it in the cloud. But they want the benefits of the cloud. So for example, Azure Managed Disk of 3 copies with high reliability, backup, snapshot, all of those features without doing that development. So one of our hero customers is called Epic Health. So if you go to many of the hospitals and stuff,
I was at the doctor's this morning and they were actually using it. It was kind of cool.
Wonderful. And so it's not just one instance. They have multiple instances based on the hospital networks. So the smaller hospital networks, they were already on Azure. We have a great partnership. But they also have some on-prem customers where these are medical records. They need to be secure, they need to be backed up, and they need to be performant because it is connected to a live database to do whatever updates to the medical records. So the two things they wanted to push on is what we call in storage is IOPs, IO operations per second. And what that happens is when you are running a database and you're updating it, you do small updates to that. And so you care about how many IOPs we do that. And so what we did is we not just increased it by 20 or 30%, we actually increased it by 2.2x. So we went up to 400,000 IOPs. And the other part of it is once you have this database, you need to back up just to make sure you never lose a patient's record. And there's multiple different types of backups they do. One is to just take a snapshot to do data analysis on that data. Another one is a true backup copy disaster recovery of Azure, like just disaster recovery. And so for that, they need throughput. It's not small bits of information, it's just sending the whole database. And so the key win there for us is they have an internal metric on how large of a database they could run on Azure, and they were able to run a database that's twice as big. So they're able to move more of their hospital networks onto Azure without being on-prem.
And so I came out of the SQL Server world originally, and we sort of from a design perspective, we throw around terms like IOPS and load, and that's not a super easy thing for most customers to translate to their workload. Do we have guidelines that say, hey, this is order of magnitude, if you're not hitting this number of transactions per second, or if you're not, go look at this perf counter in DB2 or this perf counter in Oracle, and that'll sort of translate. Like, do we have some ways that customers can help make that translation? Because again, the drive vendors and us talk about those, but the average DBA is like, I just run queries and my workload does what it does.
Yeah. So the approach we have for that is partner with the database. We call them middleware. I don't know if there's a proper term for that.
Yeah.
The middleware
Okay.
companies the SQL, the Teradatas of those worlds to optimize. And we do the same on the networking side as well. But it's partner with them to say, hey, if you're using Ubuntu Linux, make sure you're using this version because it has the right optimization when you're trying to push a lot of throughput through an NVMe interface. And that was not fixed in a 4-year-old version of Ubuntu, that sort of thing.
Okay,
and
okay, go ahead. Sorry.
So what we try to do is partner with those database vendors who do push these to say, here are best practices, here's how you tune for it and stuff.
Okay.
But I will admit, like some of the smaller vendors, we do want to get the FAQ link out and get people educated on this to help them get the best performance.
Okay. Yeah. So if I understand, it's really more about we're making sure that the third-party vendors, right, the database vendors, which yes, SQL is us, but conceptually, they are sort of setting their customers up for success. We're working with them to make sure that happens. That way, again, the customer generally doesn't have to do a whole lot. If they think they need it, get it. You get the benefit. If you don't need to set it up. But you're sort of set up for success either way. Great.
Yep.
You mentioned Siri earlier there about security. And I saw some mention of things like Cerberus and some hardware root of trust and stuff like that. Maybe if you could speak high level about like why that's important and what that provides for our customers.
Yeah, and Niko, let me know if you want to take this one.
Go for it. I'll chime in.
So we do have our own Cerberus. So to be clear, like Cerberus is a secure root of trust that goes through a lot of certification. But we wanted to make sure our offload hardware has a separate hardware domain boundary. So it's not the same root of trust as an Intel CPU on a motherboard. It's our own separate and we are independent. And so we could manage revoke keys and do whatever completely independent of the host CPU, and we're not exposed to any vulnerabilities on their end. That's at the sort of the base layer of root of trust. But beyond that, to our customers, whether it's storage or networking, and I'll tee it up for Niko to talk about the encryption they do, is once we have that trust that's fully rooted on Azure Cerberus root of trust protocol, which we have full control over, is what are the things that we could offer to share that trust with the workload, whether it's storage or networking. And with that, Niko, do you want to talk about VNet encryption that we enabled as well?
Sure. And before I jump into that, though, one of the things that Siri mentioned earlier, I don't know if you guys caught it, was the design of Boost. Right, it has FPGA, it has an ARM SoC with its own cores, its own secure Linux operating system that runs a lot of this. So Cerberus
and
plus,
just for our audience, that SoC is system on a chip.
System on a chip.
Yeah.
Yep. It has its own cores, its own secure Linux OS, built internally in-house by, again, another amazing sister team that we have. And so all of this leads to the security promise, right? So then the security posture when you're running your VM on a node powered by Boost, right? That's the hierarchy. And again, with the encryption where we encrypt packets and decrypt them on the other side, customers also get that extra layer on top of it. So when a customer zooms out and says, hey, whether I do something or I don't, and I just want to run something, out of the box with minimal changes, or I want the flexibility and knobs to configure things, we pretty much point them to certain VM sizes, which we know will run and land on a Boost enabled node, which is like, hey, how do I guarantee that I always run here? And we tell them, okay, you run, and we have them enumerated, I think, on the page that Siri mentioned earlier. And then from there, you then can layer on the additional features of like, oh, I now want the VM to support the VNet encryption. I now want this. And if that all ties together, all you get is a better experience with, again, the performance, the security, and all the things that are tied together.
I believe one of the features you mentioned early on was when doing updates, it kind of does a minimum downtime of the VM of some sort, right? Was that a feature that was mentioned? Can you explain that a little more? Just curious how that works.
Yeah, going back to customer principles. Customers say, hey, I love all the things I get in Azure, but a big feature for me now for my mission critical workload is I have the speeds, I have the pricing. I now want to run my system, and I don't want to know when you do things. And you keep me secure, keep me updated, but minimize that impact. And so the Boost I guess I don't want to call it the stack, but the technology, the topology of it enables us to be able to take software drivers updates and get them onto a path where, let's say, an action today to update a driver, let's say the networking driver, something that's running, and have maximum connections per second and maximum flows, and your VM is running at its fullest. We have a technology that we're rolling out to enable that update to happen and in under 3 seconds, and in most of the cases under a second, what we call our sub-second North Star vision. Customers have asked for this, and again, the exact times we're working on it, but by component though, in general, one of the principles we're working towards is minimizing that across the board for things that happen on a host, on a node, or whatever word customers use, but essentially that blade. And it's a feature, by the way. You might some call it a back-end update, but for customers, that is a feature that is as important as anything else that they're running on the node.
I'm curious,
Siri, did I cover that correctly? Is there anything else I might have missed on the maintenance promise?
I think that's it. And just how we get there is by isolating customer workloads from Azure infrastructure. It gives us the ability to do what Niko was describing.
Yeah. I was wondering, how does that correlate to, I think it's called Project Flash, right? Which gives us the availability of the VM. And so now you're doing these updates for short periods of time. Is that reflected as down when it comes to availability calculations, or is it just like, considered normal operating?
If I take that, so when we look at the full downtime accounting that happens for some customers, the duration of that, I don't know, the update or that activity could be considered down for them because the connection, you're going to do those little gray out where new connections are not established or existing ones slow down, and then they might time out. And to them, it's like, oh, that's a downtime for me, whether the VM rebooted or not, or had an issue. And so to most of the what we call the mission critical customers who are running workloads that just cannot handle 5, 6, 7, 10 seconds of pause, that's what we're going after, which is separate from a full hardware failure or where the node experiences a full downtime where every VM reboots and they go down for minutes. So we're trying to minimize that what we call the 0 to 10 or 20 seconds of updates.
Great, thank you.
Yeah.
So this is great. I love the overarching message of you don't really have to do anything to get the benefit. It's like sort of getting it mostly for free, which is great. Any last concepts or thoughts that you want to leave our audience with? Otherwise, I think, when you get the triple the consumption of Boost next month, you're welcome. But, any other thoughts you want to leave our audience with?
Just one. So we're going to share some links, and we love to hear feedback. As Niko mentioned, there's multiple generations of this hardware, so it's not we're one and done. There's more improvements and enhancements. So take a look at the FAQ, take a look at the intro sites, and get us feedback if there are additional areas. We love to hear from you.
Yeah, and there's a good clear list there. We have a future program manager, I see. On the call.
He's super interested in the tech, right?
We're hiring.
I'm training my grandson already.
Yeah, and you'll see a list of VM sizes or VM families that take advantage of it. 2024 is a big pivotal growth year for us. So there's going to be even more coming out, which is virtual machine powered by Boost or Boost enabled, and so it's going to be a big growth year for us, and that list is just going to continue growing. So that's going to be our source of truth for keeping track of, hey, I don't see something on there that fits what I'm running today. I don't know, compute optimizer, memory optimizer, SAP or something. That list is just going to continue growing. So continue to reference that, look for our blog posts, and then look for more announcements in about, I think, 4 months at Ignite.
Yeah, and I do think one thing, like if my understanding is correct, basically going forward, everything will look like this. Like this is not intended to be, you got to get these special SKUs in the future to get it as well. Like this is really about we're rolling out new hardware, and obviously that doesn't show up everywhere at once, but over time, like this is what we are building, this is what we were installing in our data centers over time, right?
Yeah, if I may, and Siri jump in, that's actually a good point. This is not a niche esoteric offering. Right. This is going to become mainstream where almost every VM size or family will have a version of Boost on it.
Okay. Great.
Correct.
Yeah.
Awesome.
And just if you don't use VMs, you don't directly interact with it, but the containers or the services that run on top
We're all
of it
sitting
will.
on it.
So,
Yeah.
for
Yes.
example, OpenAI, it still gives you a query response, but it still uses Boost underneath, but you just don't see it directly.
Yeah. Yeah. Absolutely. Absolutely. Well, great. No, y'all, this was awesome. I'm gonna go back and keep digging into some of the tech under the covers. I like to, as y'all know, I typically run into y'all when something doesn't work the way that I expected. But I think I've heard lots of positive things from our customers that are using, these capabilities. They do love it, and the onboarding is generally pretty easy. So thank you for coming on. We'll, when you have more announcements, we'll have you back in the future.
Thank you for having
Great.
us.
Thanks, folks.
Thank you.
Okay, see you.
Thanks, folks.